Hello friends, in this presentation we can see a small demo how to execute the threat model for IoT devices or embedded devices. We already saw how to create the data flow diagrams using OWASP Threat Dragon Tool. Suppose if you want reference video, I have mentioned in the description box. You can take that links and open the specific video. Today we can discuss one of the IoT device, how we can execute the threat model and how we can identify all possible potential threats using OWASP Threat Dragon. That aspects we can see in this demo. I have created a small data flow diagrams and I identified the threats. I am opening that project. Okay, here you can see the project name threat model for IoT devices, and this is one of the sample and reference purpose. Suppose if you click the edit, you can see the title and the owner is my name, reviewer my YouTube viewers, and high level system description. System description we can give like this is IoT device, and the device have major components like microcontroller, flash memory chipset, Bluetooth chipset, MQTT protocol stack, HTTPS, SSH. Assume that these services are running on the application of the embedded device. So the device have the Linux based OS. Assume that the device have the embedded Linux based OS. And the scope of the threat model, assume that we need to create the threat model and identify the threats and the security controls, embedded hardware layer, bootloader layer, kernel OS, device drivers, Linux OS, application services, and communication interfaces like USB, Bluetooth. These aspects we need to identify the threats. And out of scope, you can see I given the out of scope IoT cloud. So cloud side of the threats we are not identifying, and we are focusing here only on the embedded side, embedded related threats. And the assets in the hardware layer, microcontroller, Bluetooth chipset, flash memory, that is the major assets in the hardware layer. And bootloader layer like bootloader configuration, digital signature algorithms, digital signature keys which is used for the bootloader, and kernel again digital signature and keys how we are handling to sign the kernel files. That is the assets. So device drivers access control list like making the blacklist whitelist configurations, so that implementation we considered as one of the asset. And OS user access control, disk encryption configuration. So these are all the major assets considered in the OS layer. And application layer like MQTT configuration, TLS certificate, keys, registration workflows, HTTP user configuration, user credentials, DB credentials, TLS certificate configurations, SSH configuration, SSH keys, and firmware code signing, digital signature algorithms, keys, and data handling. Assume that this is the medical based device and the device is handling patient EPHI data and critical data like application services critical data like HTTPS credentials, MQTT credentials, TLS certificates, keys. So these sensitive data and critical data handling by the application. So I have given here the high level system description of the embedded device. Now we can go to the diagram. Okay, if you open the thread, you can see I already created one of the data flow diagram to execute the threat model for the IoT device. Okay, here we have, suppose if we take any IoT device or any embedded device, so they have different layer of the architecture, right? Example, first one is hardware layer. On top of the hardware, bootloader layer, kernel and OS, device drivers, application services. On top of that, they have the interfaces. Assume that based on our specification we saw, they have Ethernet. Over the Ethernet, it will communicate to cloud with MQTT protocols, and they exposed SSH connection to connect the SSH clients, and one more service they executed HTTPS, so that HTTPS clients access the web application from the device. So this is what these services are exposed over the Ethernet. And the second interface, Bluetooth. They have the Bluetooth connection. So using this connection, the host device can pair and they can communicate with the device over the BLE, Bluetooth communication. So that is what the diagram here I given. And USB. USB, okay, next one USB. Assume that the device have the USB port, and using this port, host USB devices can connect and they can communicate over the USB port. And assume that we have another interface like serial port, RS-232 port, so that the devices are RS-232 based devices, they can connect with this port and they can communicate with the device. So this is what the architecture I given in the data flow diagram. And if you see, we have different trust boundaries, right? The first trust boundary here, this is onboard trust boundary. Suppose if a hacker want to execute any attacks in this area, they need physical access of the board so that they can execute the threats in this area. So this is one trust boundary, that label I given onboard trust boundary. And the second trust boundary, here you can see the device have the Ethernet interface. One connectivity they communicating with the IoT cloud. Second connectivity they communicating with the SSH clients. Third connectivity they communicating with the HTTPS clients. So this is, assume that these connections are exposed over the internet. So I give an internet trust boundary. This is second trust boundary. Third trust boundary, assume that the device have enabled the Bluetooth. If we have the Bluetooth signal access within the device, nearby device area, we can access that, we can pair that device, and we can, that means attackers can try to execute any attacks over the Bluetooth interface, right? That is why this is the third trust boundary. Bluetooth BLE is third trust boundary. And the fourth one, USB. Suppose if the hackers have physical access of the device, like USB port device, they can inject some malicious drivers or malicious host devices and they can execute the further attacks, right? So this is also one of the trust boundary. Meantime, if the attackers have serial port interface of the device, he can connect malicious drivers or malicious devices with the serial port and he can access the attacks. So this one is third trust boundary. You can see in this diagram 1, 2, 3, 4. 4 trust boundaries are considered for this device architecture. So this is what we need to create clear data flow diagram when we want to execute any threat model. This is one of the sample tool, OWASP Threat Dragon. Using these tools, we can create and we can identify all possible threats for the devices also. Okay, also one more input here you can see IoT cloud side threats we are not considering. in this assessment. So that is why I marked as out of scope. And serial port host device side threads we are not identifying in this assessment. So that is why not in scope. So not in scope components, one is IoT cloud and the second one serial port host device. So this we are not considering. This we are not considering and we made it as out of scope. Okay. If you go the manage threads, I already identified list of threads. We can see, you can select the component and you can see each component have different types of threads. Suppose assume that if we take the hardware layer, so there what type of threads may occur? First one is insecure control chipset and second one insecure flash chipset. Suppose, okay, the first thread insecure control chipset. Suppose assume that the microcontroller itself not supporting the secure boot mechanisms, hardware mechanisms. So we can't implement the trust of chain mechanism, secure boot mechanisms, right? So that is why we need to consider hardware assets also one of the scope for our threat model and we need to identify. So we need to select the hardware and it should support the bootloader configurations, bootloader implementations. The hardware should support the bootloader implementation. And the second one, insecure flash chipset. So when we storing any sensitive customers data in the flash memory, we sometimes we need to encrypt the data using encrypted blocks of the flash, right? So that sort of security we need to consider. If the hardware itself not supporting, it may create a threat. And insecure Bluetooth. Suppose if the Bluetooth chipset have any open issues, it will create the threats in the Bluetooth communication or Bluetooth stack, right? So that also one of the asset we need to consider and we need to assess when we execute the threat model. For reference purpose, in the hardware layer, I considered three threads. One is insecure controller chipset, insecure flash chipset, and third one is insecure BLE chipset. So like that, each component, all possible threads you can see when we click the components here. So what I will do now, I will download the report, the sample report, and we will see, we will go through what type of threads may occur, what type of threads are possible in this architecture. Here we have the report. We can download the report, save as PDF. Okay, this is the threat model report. The owner and the reviewer's contributors name and the high level system description. You can see whatever we updated in the Threat Dragon tool, that information you can see it here. And this is the data flow diagram. Again, hardware layer, bootloader layer, kernel, device drivers, applications. On top of that, Ethernet interface, Bluetooth interface, USB interface, serial port interface, and you can see the host devices or application clients here. So suppose if we take the hardware layer, here you can, we already saw this thread, insecure controller chipset, spoofing related threat as per the stride methodology, and this threat is open and this is high priority. So that is what the status we can see it here. And description, unsupported security controls such as secure boot mechanisms like TPM, OTP in the controller hardware. That is the threat. So mitigation, secure version of controller chipset we need to select and it should support the secure boot mechanisms like TPM. TPM nothing but trusted platform module, right? So or OTP, these mechanisms the controller should support so that we can implement the trust of chain or secure boot, right? So that is what this is one of the threat, and we need to mitigate like this. And the second one, insecure flash chipset, again spoofing, and it is open, high priority. Description, you can see unsupported security controller, unsupported security controls such as encrypted blocks, read write permissions. So these configurations are not supporting by the flash hardware. That means the attackers can read the data, or he can spoof the data from the flash, right? So that may occur later. So this is one of the threat, and we need to mitigate by providing proper security controls. What controls? Secure version of flash memory, which it should support the encrypted blocks, proper read write configurations. So this is what we need to consider. Insecure BLE chipset, spoofing, open, high priority. Insecure version of BLE chipset, and assume that the chipset have known issues. Insecure BLE chipset, and mitigation, secure version of BLE chipset we need to consider for our design. Okay, next layer is bootloader, missing secure boot. Assume that we need to consider the secure boot implementation. Suppose if we are not implementing the secure boot, the tampering may happen in the boot sequence, right? So that is why the missing secure boot also one of the threat we need to consider. Again, the mitigation, secure boot implementation is the security control, and we need to consider. Second one, insecure digital signature algorithms. Suppose if we have any weak digital signature algorithm or weak key handling practices, if we have, that may create the threats later. So that we need to identify the possible threats. We need to consider insecure digital signature algorithm implementation, also one of the threat. We need to mitigate that. And a secure version of hashing or digital signature algorithms we need to use. That is the mitigation here. And the insecure key handling, here you can see the key length, key rotation. So this type of implementations we need to consider when we implement the secure boot configuration. And the kernel and OS related threads, missing kernel signing, missing kernel signings. We need to sign the kernel also, right? As part of the secure boot. So that is why the kernel sign or a trust of chain we need to consider, and we need to implement. Trust of chain means we know, right? Suppose assume that here we have the hardware, bootloader, kernel OS, device drivers, then application services. Assume that if we have proper secure boot and trust of chain implementation, the hardware will verify the bootloader. If it is trusted bootloader, then only the hardware will allow to boot the bootloader. Otherwise, it won't allow to boot the bootloader. Then the bootloader will trust and verify the kernel and OS using the digital signature verification, and the OS also will verify the device drivers. Then on top of that, the application services also, the digital signature checks will happen. This is what the trust of chain layer by layer we need to implement. So then only we can prevent the tampering on the boot sequence or OS tampering, device drivers tampering, application services tampering, or firmware tampering. These type of attacks we can prevent when we implement the secure boot and the trust of chain mechanism. So that is why we need to consider the kernel signing also one of the security controls. Okay, and the drivers also we need to sign, and application layer also, application layer like MQTT, HTTPS, DB, SSH, firmware, these also are our assets, right? So here uh, in the application layer you can see missing TLS. Okay, next layer is application layer. Here I given some of the sample possible threads for the MQTT, HTTP, DB, SSH, firmware. Here you can see missing TLS secure channel for MQTT. Their recommendation is TLS based secure channel we need to implement, and misconfiguration of the TLS certificate. Their TLS secure implementation certificates we need to provide, how to implement that best practices we need to provide, and missing mutual authentication for MQTT. So there we need to implement the mutual authentication using MTLS or equivalent mechanism, right? So that implementation we need to consider, and missing authentication for HTTP. Suppose if we have missing authentication, suppose if there is no authentication for HTTP service, any attackers can log in into the URL and they can execute further attacks, right? So strong credentials, strong login mechanism we need to consider, and missing secure configuration for HTTPS. HTTPS related secure configurations we need to implement here, and misconfiguration of HTTP service like accessing the SSH service through root access, and insecure encryption and hashing exposed over the SSH service. So that sort of issues also we need to identify, and missing authentication for DB. So we need to implement a strong login mechanism for DB, and DB related misconfigurations like encryptions, hashing and storing, restricting within the local access. So these sort of configurations we need to do. Okay, then the Bluetooth related issues. The first one is Bluetooth, insecure Bluetooth stack. If the stack itself have any known issues that will impact, so secure version of stack we need to consider, and missing USB host device authentication. Assume that if there is no authentication or identity checks not implemented, any hackers can inject malicious devices and they can access the USB device, right? So that is why we need to consider the device based authentication or identity checks using the authentication identity checks using the algorithms like ECDSA or some other mechanisms, and missing encryption data communication over the USB. So we need to encrypt the USB data also. Since we are handling the customers medical related data, we need to consider the encrypted data also over the USB, and USB drivers restriction. If required, we need to restrict and we need to allow only specific drivers. So that sort of blacklist, whitelist we need to implement here. Insecure USB enumeration and polling configuration. When we connect a new device, there the enumeration and polling will happen, right? That securely we need to handle. Otherwise, the trusted device initially they can connect and immediately they can remove, and they can connect with the malicious device using the polling configuration. They can access into the embedded device. So these sort of threats may occur. So enumeration and polling also one of the important consideration we need to do. Missing USB port device authentication. The device based authentication also we need to consider if required. Again, serial port. The serial port here, missing serial port drivers, we can restrict the drivers using the blacklist whitelist mechanism. So that controls we need to consider to prevent the serial port related. Okay, BLE host, missing device based authentication. Again, if we are allowing all the device to pair with our device, so any the attackers can easily, they can pair with the device and they can access the data, right? So that is why in the USB communication also the device based authentication we can implement if it is required. And missing encryption data, over the BLE also we can encrypt, and we can over the BLE also we can encrypt the data and we can deliver it. Okay, also you can see IoT cloud is out of scope and serial port host device is out of scope. So this is what we need to identify the all possible threats when we develop the product, and we need to provide required security controls. It is not only in the architecture or development phase. If the device already exists and it is running in the production, we can review the architecture details and we can identify all possible threats using this methodology, and we can provide required security controls to mitigate the threats or to mitigate the risk. So this is what we need to follow the threat model for embedded based device or IoT devices also. Okay, that's all today's presentation. I will see you in next session. Bye.